Let's look at first differences. That's a method to test if a table of values is linear. What we want to look at is to see if my y values change at a constant rate. And we have to make sure that our x's are all also changing at a constant rate. So let's first make sure that our change in x is consistent. So if I have 1 minus 0, that equals 0. 2 minus 1. 3 minus 2 is 1. 4 minus 3 is 1. So my change in x is 1. Now let's look at our y values. We're going to calculate our first differences, you take the bottom number minus the one above it. So first 32 minus 22 equals 10. 42 minus 32 equals 10. 52 minus 42 equals 10. And 62 minus 52 equals 10. So because my y went up by the same amount, so there's my change in y, these are my first differences. Because these are all equal, that means this is linear. So since my first differences are equal, therefore this is linear. That's great. We can also look at this table of values and we can figure out our rate of change. Let's do that too. Okay. Well, how do we calculate rate of change? Well, remember, rate of change is just my change in y over my change in x. My change in y we saw is 10. And we saw that our change in x is 1. So our rate of change in this case is 10. All right, let's do another example. All right, let's look at, there's example 1, example 2. Should we do one more? Okay, great idea. Just to make sure we've got it. Example 3. This time, let's see, there's my x, there's my y. Let's do -4, -10, -1, -5, 2, 0, 5, 5, and 8, 10. So can we do first differences on this one? Let's make sure my x's are all increasing by the same amount. Otherwise, it doesn't work. So bottom minus top. -1 minus -4 is the same thing as -1 plus 4. So that's increasing by 3. 2 minus -1 is the same thing as 2 plus 1. So we've gone up by 3. 5 minus 2 is 3. 8 minus 5 is 3. So I can see that the change in x is 3. Now let's look at our change in y. Bottom minus top again. Watch your signs. -5 minus -10. Same thing as -5 plus 10, which is 5. 0 minus -5, so 0 plus 5 is 5. 5 minus 0 gives me 5. And last but not least, 10 minus 5 is 5. So therefore my change in y is 5. So I can see that my first differences are all equal. Yay! Finish it off. Since first differences are equal, therefore linear relation. Let's extend this question since it's a linear. Let's also check our rate of change. Remember, rate of change is change in y divided by my change in x. I've seen that my change in y is 5, and my change in x is 3. So I know my rate of change is 5 over 3. Don't forget, our other word for rate of change is slope. So if the question asks for slope, well, we just found it. Our slope is change in y, change in x, which is equal to 5 over 3. Ta-da! Well done. Okay, seems like I accidentally paused it when I worked through example 2, so let's work through it again. First thing we want to look at is to see if my change in x is constant. So I can count by 2s. 0, 2, 4, 6, 8. So I'm clearly going up by 2. On my y side, we want to do bottom minus top. So we've got -1 minus -3. That's the same thing as -1 plus 3, which is 2. Next pair, 3 minus -1. That's the same thing as 3 plus 1, which gives it 4. Next pair, 9 minus 3. That equals 6. And last pair, 17 minus 9 equals 8. So if we look at our first differences, we've got all different values. So since our first differences are not equal, therefore this is non-linear. Sorry.